Okay, I had to restart the recording. Good. Now what I've done is I've installed a fresh Lubuntu on VirtualBox, and now I will do some updates, and then I will install the toolchain required to build a Linux for the HPS for the Agilex 5. As I mentioned, I have already done a video. It was a couple of hours already, but due to some problems I had to restart. But maybe one sentence or two on the ideas of this video. So I'm not an expert as well. I try to learn and share my knowledge, and this will be basically a live coding, live debugging, live research video. And yeah, I hope you will like it, and I hope this video will be also maybe alongside your video motivation to work with me through YouTube on building new great stuff. And okay, good. This is the Quartus Prime Pro software of Altera, of Intel, which is now again becoming Altera. I am doing these videos. We have currently date. I don't know the date. Yeah, 26th December 2024. And beginning of 1st January 2025, Intel will split Altera from Intel, and they will become a standalone company. But Intel will be the major shareholder of that company, but Altera will be standalone again. So just a side note. Okay. Quartus. This is the software for building great stuff, and this is the Agilex5-EAGLE board. Let me show that to you. There is a great Agilex5 AXE5-EAGLE. There is a great Agilex5 dev board from Intel and Altera, and I'll be using this one to learn more about Altera and Agilex5 and so on. The Agilex5 is interesting. It has a quad core, a dual core A76 processor and a dual core A55. It has PCI. This thing has LPDDR4 memory, two of them. One is connected to the HPS, the other one is on the FPGA region. And yeah, it's basically a great dev board. And what we will do is we will build an SoC, a system on chip design, where on the one side we will run Linux, and on the other side we will have our FPGA stuff, and we will connect them together. And to do this, there is some example designs, and one of them I have here open. I basically did nothing. I just unpacked this thing. I compiled the bitstream, and I have all the code, and we could now start analyzing this one. So the golden hardware reference design, GHRD, is the top project. And here in this top project, which is a .qsys is a platform designer tool by Quartus, by Altera, to really see the components and connect them together, and then generate the system and generate the bitstream. And basically what we have here the whole system, and here we can see the schematic, and this is the HPS subsystem. We can open that here, and here we can see the Agilex5 subsystem. This is the external memory interface IP, which is connected to the Agilex5 on the Linux side. Let me show a picture to that. Not this one. Not this one. I have another one somewhere. Maybe here. No. Here. This one. This is the bank 3A, which is connected to the HPS. And here we have the bank 2A, which is inside the FPGA. Both can be accessed through the HPS. This one is directly connected to the HPS. This picture is not news. There is an update in the code, but I will show the code directly. But to understand, the bank 3A is directly connected to the HPS, and the bank 2A LPDDR4 is connected to this external memory interface subsystem. And from here, you could access it from the FPGA region, or you could access it from the HPS region. And the HPS region is the hard processing system or something like this. Okay, good. Now, what I would like to do is show the schematic of this thing. Okay, just a side note, this is something I was looking into, and then the system stopped. Let me see what Quartus was doing. I have some issues with that installing. I don't get it. Why is this happening? I cannot install the updates. Hash sum mismatch. LibreOffice. No. I really don't get it. I really don't get it. I will do something else. I will remove this. I will delete all files. Then let's start a new one, Lubuntu. What I will do is I will take this one. I will say yes, but I will try to disable the NUT. It shouldn't get any data from the internet. I will just do a plain installation of this VM, and then later I will remove the installation image, and then I would like to get all the updates through the system. Okay. Good. Install. Yes. Na gut. Well. Wow. Okay, now we've installed this virtual machine. Let's stop it and remove the image. Then we should be good to go. Hopefully. Remove. Yes. Now I will activate the network. I will change the MAC address start. I don't get it. No bootable medium found. Huh? It should have installed on the machine. Okay. Let's plug in the storage again. This thing, choose, okay, start. Okay. Why is this so hard? This was really easy in the past. Okay. Worst case scenario, I will download Ubuntu to be on the safe side. Ubuntu download. Six one three two. Oh. It's 20. Okay. Now, what I was... Yes, okay. That's the platform designer. This is the external memory interface. And this connector is the direct connector from the HPS to the IO96 memory bank. Let me show that to you. There is a nice overview here. That's the IO96 bank. It goes through the NOC to the CCU, and from the CCU it goes to the dual core R76 and dual core A55. We have this thing as well, and we have this thing as well, and we have this thing as well instantiated. Let me show that to you as well. Okay, doesn't work. I've lost the connection. Now it's here. Remove this. This is the lightweight HPS to FPGA connection. This thing goes right to the peripheral subsystem, and in the peripheral subsystem it goes to the peripherals, and these are mainly IOs and stuff. You can control them. Here, this is that thing. It goes to that bridge. From the bridge, it is then mapped to the respective slaves. This is a slave input. Then the slave input is transformed to a master output, and the master output controls these things. Here we have a reset mechanism. This is the clock in, clock out. I did some research on this component. My feeling tells me this clock bridge is necessary if you get a clock from outside into the FPGA, but this clock is already in the FPGA. My feeling tells me we wouldn't need that, but I guess it doesn't harm to have it. This is our system clock. The system clock is 200 megahertz. And the system clock you can also see here in the schematic. If I will be able to find it. If I will be able to find it, how can I find it? How can I find it? Let me browse through the schematic. U52. Maybe here somewhere. LPDDR. This thing, LPDDR ref clock, if I search for LPDDR for ref clock. Let's try to find it. Ref clock. Where is it? Clock. No, this is not that thing. Fixing. I have it. This component is the clock source, and here we have this clock, and this clock is our reference clock which we get into our FPGA, if I'm not missing it. Let's see. Let's see. We will do it. Clock subsystem. This is the clock. This is the clock. This is the clock system clock. Now let's go to Quartus and then the assignment editor and then search for clock. There is no clock. Clock. Let me try to find it. Da. 3BO, 3B0, that's this thing. 3B0. And this is 200 megahertz. And this thing has multiple clock outputs for USB, for LPDDR4, for the two of them. And it has two clock input sources. I have to research why we have this clock input and that clock input. But yeah, it has two clock input sources, this chip. Okay, let's see what is our installer doing. Yeah, I know. It is already installed. Now let's do a reboot, see what happened. Again. Okay, I will do a VirtualBox update. Power of the machine. Remove. Delete all files. Check for updates. What? No. Ah. No, that's not the right way. Okay. Now what I'm trying to do is I try to install that sudo apt auto remove all the things I don't need and install the latest VirtualBox version. Good. Now let's try it again. New Lubu. Okay, good. I cannot read it. 50. What I can do now is there is a virtual machine I have which already contains the toolchain. It's this one. I will try to unzip it, extract here. It's already here. No, that's okay. Stop. I will delete this. I will delete it as well. Let's start the installer. Extract here. Empty trash. Yes. Language. American English. Next. Okay, I hope it will work now. Okay, let's continue with QSys. Yeah, this is our clock. I showed that. The video subsystem we will analyze in a later video. This is basically the FPGA to the HPS bridge. It is connected inside, but it's not connected outside to some FPGA logic. But we could instantiate something and then connect it here. And from here, we could then address the internal of the system. Let me show the FPGA to HPS. It is here. Where is it? This one? Not this one. This is top down from here to here. Yeah. Okay. And basically, that's the most important one. Lightweight HPS to FPGA, and then the normal HPS to FPGA. This thing goes down here. It comes from here to here to here, and this is the second EMIF subsystem. Like this one here inside the EMIF subsystem is the main external memory interface connection with that IO96 blocks, and this one is the other one. And yeah, basically here we have an address expander, which is if you have, for example, the SoCs sometimes or some processors of Intel, they can only address, for example, 1 gigabyte. And if you would need to add, and your memory has, for example, 4 gigabyte. Okay, and now how to use that 4 gigabyte with only 1 gigabyte address space? You could use that address span expander and then have 4 windows of 1 gigabyte to address the 4 gigabyte. Let me show that to you. Now I can see it here. Here we can see it. For example, an HPS subsystem has an address space of 1 gigabyte. Using the FPGA to HPS to FPGA, the address span extender enables the SoC to address all the address space in the FPGA using multiple 1 gigabyte windows. For example, here, if a processor can only access 2 gigabyte, but the system has 4 gigabyte memory, the extender provides 2 times 2 gigabyte windows, and with these windows you can then address them. No? Okay, that's that. This is the JTAG IP to connect via JTAG. And the address expander is connected to the JTAG. And the reason why I didn't get it very much, but let me show the thing why I didn't get it. This is in the EMIF subsystem. Let us open the EMIF subsystem. It's here. I will open that. Here we can see the master of this JTAG adapter. This comes here, and from here it's directly piped to this thing. And this AXE is connected to 2 masters. So one is the master bridge, which is connected to the outside world. Let me show that. Master bridge. Well, master bridge. This thing is connected to the outside world, and this thing is connected to the HPS to FPGA connector. Okay, that's okay. We understand this. But why we have that span expander which then connects here? I guess this has something to do with the address we are dealing with, and Quartus doesn't allow to connect two addresses, like 2 axes where we have addresses without having some logic in between. I don't know. Let me open that thing. Burst properties, sub window, like we also have no real offset here. It's only 1 gigabyte. I also don't see some intelligence here. It's just some pipe or something. Yeah. The slave has a word address bit width of 25 bit. Yeah, that's just a mapping. But why does this thing have 25 bit? Okay, I don't get it. Okay. But I guess it's clear. The USB stuff we will analyze later. The Emacs stuff also later. But this is already a good feeling on the whole system. The HPS, the peripherals, the EMIFs, 2, which one is inside here, one is inside here, then the clock subsystem, which I showed in the schematic, the video subsystem, we will look later into it. This is a JTAG adapter again, and basically that's it. Yeah, I will now close this. No. Now what is missing is we have to get our toolchain running. Now we have to wait for this thing. And our existing VM is still unpacking. Yeah. I'll go and grab a tea and then we will continue. Okay, the installation is now finished. And also this thing is also finished now. In that folder we have the Agilex 5 VM. I will copy and paste it here. Move this thing. Yep. Perfect. Now I will do an update of the whole machine. Oh, good. In the past version I couldn't do this. There was some bug. But this looks good. I would like to build up the whole toolchain from scratch. Then we can learn a bit more. That looks pretty good. It's the speed. By the way, I use No Machine as a remote desktop tool to connect to my remote Linux. This takes a while. Okay, now the install finished. Okay, perfect. It works. Good. Good, good, good. Good. Okay. Now here I have, yeah, let's first install the guest editions. Okay. Okay. Define a top folder. Perfect. Okay. Now we have exported the path to the top folder as the variable top folder. Yeah. Okay. Okay, this is the ARM Trusted Software firmware. By the way, what we are trying to do is this here. Through Quartus in Platform Designer, we will get the Agilex 5 top bitstream. And now what we need is the first stage bootloader, the U-boot. To get this, we need the ARM Trust firmware. And this is what we try to build up now. Yeah. Just to open this page, I would like to better understand this. Oh, which one is this? Version 3 is already there. Let's go with the version 2 one. Let's see what will happen. We first have to install Git because it's already set. Copy paste doesn't work. Machine devices should report direction. Hey. Okay. Ah, shit. I have to search in that folder. No, export it. No, git clone. Good. What is this? Was ich nicht verstehe, that's German. What I don't understand is the compiler should be the ARM compiler. Let me install this one as well. I will just close Quartus to get some RAM. Okay, let's do a break here and then dive deeper into this thing. Okay, I will do a break here, and then next video I will try to dive a bit deeper into the whole toolchain. Thanks.